Hello there. My name is Professor Van Graff. I am so glad that you are here today, because we are going to learn about one of my very favorite things. You guessed it. The Van de Graaff generator. We are going to talk about where the Van de Graaff comes from, how it works, and why it is useful. Be warned though. This information could be a bit shocking. Ha 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 ha. Hi. Thank you for the invite today, Professor. I am very excited to share with these students. My name is also Van de Graaff. Robert Van de Graaff. I am currently working under a fellowship at Princeton University and my latest project is electric. I would like to share with you how we created the generator and what components make up this machine. The year is 1929 and my friend Nicholas Burke and I have been working on this for several years and have high hopes for the amount of charge that it will be able to reach. We got our original idea from Lord Kelvin's water dropper. Essentially the machine will work to collect charge and then we will allow it to disperse on a shell which when it reaches a high enough voltage will then discharge. It can be pretty touchy though. Here is a simple example of how the generator will work. Have you ever taken a balloon and rubbed it against your ferret? No? Well, this is what you could expect to happen if you were to perform such an experiment. The motion of rubbing the balloon on the ferret will not only upset the animal, but it will transfer charge from one type of material to the other. Here you can see in this diagram how the cloth, or the fur, is negatively charged or has more electrons and the rod or the balloon in our case is more positively charged. This is important because as the charge accumulates it creates an electric field which in turn affects the voltage. The Van de Graaff is a fascinating little machine with few but important parts. It consists of a lower roller which is rotated by a small motor, a belt, and an upper roller. Each roller is near a comb whose teeth play a role in collecting and transferring charge accumulating around the rollers. It works as a motor rotates the lower roller. As the roller rotates it spins the belt, which in turn rotates the upper roller. This rotation is important because as the roller rotates against the belt the friction actually causes a transfer of charge. The roller tracks negative charges and leaves positive charge on the belt. This positive charge is then pulled up toward the upper roller where a similar phenomenon occurs. The positive charge on the belt being deposited onto the top roller attracts the negative charge from the teeth of the comb attached to the shell. This causes a net positive charge to develop on the outer shell and will continue charging until the Van de Graaff comes in contact with a grounded object and is discharged. Now we are going to talk about the uses for the Van de Graaff generator. One of the most common uses is for basic demonstrations of electric charge. A person places their hand on the generator before it is turned on and then allows the charge to flow through them. This causes their hair to become charged and repel each other, which looks a little like this. Well, that was fun. One of the other main uses of the Van de Graaff generator is to create charge. This charge, known as a potential difference, has been known to reach voltages of 400,000. Robert Van de Graaff even got it up to 20 million volts. You would not want to touch that one. And just one last thing it was used for. It was originally invented as a particle accelerator for nuclear physics. Although not used for that anymore, it was a pioneer in the field and one of the first nuclear accelerators created. Awesome! This little invention was pretty awesome. It has been so fun to be with you today. Remember, science can shock you. Thank you, Professor. Until next time, kids. What a great time this has been. We hope to see you next week on Science Discoveries with Dr. Van. Have a great week, and remember, it's electric. Boogie woogie woogie.